Hi, and hope you are doing well. I'm Jadi, and we are going forward in the top interview questions with a lot of explanations to show you how things really work, to help you exactly understand what you should do on the new questions. We are solving the array and string, the easy ones. So, best time to buy and sell stock. Interesting. Let's open it. This time, I want to talk a little bit more about the O notation. We call it capital O notation. It can show you how good a solution is to an algorithmic questions. But let's first study the problem. You are given an array prices, where prices I is the price of a given stock on the ith day. So we have 1, 2, 3, 1, 4, 9, 8. These are the prices of the stock on the 0th day, worst, second, blah, blah, blah. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So if I buy here and sell here, my profit will be 2. If I buy here and sell here, my profit will be 5. And the best one, by I can say buying, for example, here or here, no difference, and selling here, and my profit will be 7. I have to return 7. How you can solve it? And it's a very, very nice one to start talking more and more about the capital O notation. Capital O notation can show you how good your algorithm is, how efficient it is. Think about a very, very bad solution. I will going to solve with that one first, because why not? It's always good to see bad things to learn from them. One method is I want to find where is the best day to buy and sell. I can go buy a very, very rudimentary brute force, just pushing the answer. How will it work? I can start from here and say, okay, I will check 1 with 2, 3, 1, 4, 9, and 8. And we'll see, okay, my best profit was 8. Then I will go for 2. I will check 2 with 1, 2, 3. Okay, you don't need to check with these 2 because these are in the past. So 2, you will check it with 3, 1, 4, 9, 8. Do I had a better solution? Answer, no, because the best one was this one, which is 7. So I will check 3 with all of this. I will check with what one of these. I will check 4 with these 2. I will check 9 with 8, and I will have the answer. Practically, I am checking every single possible solution in the most idiotic way. If you solved it like this, sorry. I just called you idiot, but you are learning. This is the point. Idiot, that was not good, sorry. But watch, I learn about ON notation. We call your solution or what I just described ON2. Let's see why it's bad. Let's write it. Who's afraid of writing an algorithm? And we can do something fun. I will write this one in JavaScript. This is not my preferred programming language. I'm not proficient in it, but who cares? We are just using simple methods. Sometimes you can use very advanced methods in your own programming language, the one you know very well, C#, .NET, Python, whatever, using set, max, and just solve things in one go. But we want to see the algorithm. So I'm just going to write what I called idiotic. Let max profit is 0. Start from here. 4. I will say buying day starts with 0. It goes up to prices length and buying day plus plus. Then I will go with 4. Let sell day starts from not 0 but buy plus 1 from the day after. Repeat while sell is smaller than this and add 1 to it. Now I'm comparing everything with everything. I can say today's profit if I have done this buy with this sell would be prices sell minus prices buy. If I've done this, this would be my profit. So I can say if today's profit is larger than max profit I've seen ever, then my max profit equals today's profit. And at the end, I have to return the max profit. Very clear. I'm comparing everything with everything. And it should work unless I have an issue. And it's very common. You try here, it works with the samples you have, and the time limit exited. How? Cell plus plus. Okay, I am the idiot. We were not adding to cell, so this was running infinitely. And it's very common. It's accepted. So these two cases are working fine. Then you submit and you see an error. You will see it here. Why? Let's see. I'm running it. Practically, as you saw, I have some inputs. I have two nested for loops. So I'm checking this with all of the next ones, checking this with all of the next ones, checking this with all of the next ones. To make it simpler, you can imagine that I'm checking this with everything. I'm checking this with everything. I'm checking this with everything. That would be the simpler solution. And this says time limit exceeded. When I have 4 elements, how many times do I do the calculation? If I was checking everything with everything, that would be 4 in 4, which is 16, which is 4 to the power of 2. That's why we call it O(n)(2). Because we have 2 loops. This will take n elements. This will take n elements. They are nested. So for every input of the size 4, I will have 4 to the power of 2 tests. Okay, here it's a little bit smaller, but it's not important in O notation. O(n) in practically we have this, which will be n2 to the divided by 2, but this is not important because we are talking about powers. So if you remember from your maths class, n2 is like this. If you have 4, this will be 16. If you have 5, it will be 25. If you have 100, that would be 10,000. And if you have 1,000 here, you will have 1,000, another 1,000, that would be 1 million. If you have an input with 10,000, the number of things you have to do in this nested loop is to the power of 2. So that would be 10 million. And just imagine if you had an input of 1 million, what would happen? So O(n)(2) or a nested loop with 2 4s is unbelievably slow when the input increases. This is why this is problematic. There should be a better solution. If you were in an interview session and you wrote this, most probably you were not going to be employed. Unless you say, I know this is bad. This is O(n)(2) and this is very slow for the input. I have to find a better solution. I understand the problem and I'm eager to learn. Be like that. How we can make this better? In most cases, you have to think about solutions. What happened? In most of the cases, you can look for the solutions. We try to do things in one go. So if you have 4, 2, 3, 1, 9, 8, 10, 7, you have to be able to do it one go. The algorithm is like this. You start with imagining that, okay, my max profit is 0. And you imagine that your buy day is 0. So you had no profit and you bought here. Then go to the next one, second day. The price is 2. What is my profit? Okay, it's bad. I'm not going to sell. But this is a better buying price. So I will update my buying price to 2. Then you will go for the next day. It's 3. my profit is 1. It's higher than my max profit. So I will imagine that, I will save that my max profit is 1. And I'm not going to buy here because it's not good. The next day, it's 1. You bought here. So your profit is minus. This is not good. But you can imagine, okay, what if I buy here? I already had a profit of 1 here, but let's see what will happen later if I have bought here. Because whatever number you have here, which gives you a higher profit than buying here, even a better one if you have bought here. So you change your best buying price to 1. Then you have 9. Oh, your max profit is 8. Good. It is 8. So your profit is 7, not better than this. 10. Again. Okay, 9. So your max profit is 9. And you solve it like this in one go. Think about it. Try it for yourself on paper. And then you can say that you understood it. Let's write it down. Let max profit is this. Let buy price is, I can even say prices 0 on the first day I bought. So I can say check from 1, go. I can change this to by day to make it a little bit more understandable. Okay. And here I can say I will go day by day and check what's going on. I can say, for example, if, okay, by day, if prices by day, so I have the price of this specific day was smaller than my already buy price, I can update my buy price. And in JavaScript it's kind of like C, so I need this. Else I can say, okay, else I can check my profit. Else if prices of this specific day minus my buy price was larger than max profit I've already seen, right? If I'm correct, my max profit is updated to this, right? Hope this is okay. And here I can say else if, right? So I'm saying start, imagine that your max profit is 0, then your buy price is your first day. So you start. Then check all the days. Okay. And if this specific day's price is less than what you bought, imagine that you bought this day. Otherwise, if the profit you can make by selling this specific day is larger than your max profit, update your max profit and return your max profit. Let's try it. Remember, on the previous run, which was O(n) to the power of 2, time limit exceeded because input got so large that we were not able to do the calculation on time. Now it's much better because although we have more calculations here, let's run it once more. This is what some people do. Because this speed is highly based on the status of the server, how busy it is, and other stuff. So we can make ourselves faster. Some people just run it times and times and times to reach here and then say, oh, I'll solve it very fast. But our algorithm is very fast. We don't need this chart because we are solving on O(n), and this should be the fastest possible. You can do very small optimization, but practically, when we are O(n), the next step should be O(1), which is something like return I multiplied by 2. This is O(1). But here we have to go through all the numbers we have and an array. So that would be O(n). So this is so cool. I hope you understood it. The solution is a little bit not difficult, but needs a little bit writing on the paper, going through it, understand it, how it works. You won't learn just by looking. Try it in your own language, write it down, explaining to your friend. Even these kind of questions can be discussed with non-programmers. How would you do this? They would say, okay, I think about every single day. We'll check if there is a larger one, and you can discuss and give them this fancy algorithm. Have fun.